Welcome to Hardware Asylum. No RetroPC adventure would be complete without a dial-up modem. Unfortunately, dial-up networking and the BBSs that came before the internet have long been taken offline. Unfortunately, for RetroPCs, DOS-based, Windows 3.1 based, they do not have a lot of software support for getting on the internet itself. And the software that they do have available was tied to a modem and the Haze commands and being able to dial out over a serial connection to connect to a BBS or a fax machine or call somebody at their house. And that brings us to the purpose of this particular video, where we're going to be taking a RetroPC modem like this. We have a Supra FaxModem 14.4 and we also have the Supra FaxModem 28.8. This is the LC. As you can see, it is the low cost edition. That's what the LC stands for. And we basically have activity lights all the way across the front. The 28.8 was an upgraded version that had very similar activity lights here, but then off to the side is a 2-digit display that would display some of the commands that would be lit up on the front of a standard modem. Now, since dial-up networking and landline-based BBSs are no longer a thing, what we need to do is be able to take the serial connections that these modems would normally interpret and transform them into a network connection. And you can do that with certain devices that you can buy online, or you can get a device like this, which is a serial to TTL adapter that will connect to a Raspberry Pi. This is a Raspberry Pi 4. And with some software, you can make that translation from the serial connection to a Wi-Fi connection. And instead of dialing out to 555-1234, you translate that in the software to say, send me to labs.ninjalane.com, which is the NinjaLane Labs BBS. That process works perfectly. I've used it on the classic case build. Unfortunately, what happens is we have a Raspberry Pi just kind of floating around. We have this long cable connected to the back of the computer, and it doesn't look very retro. So what I would like to do is take the functionality of this and put it into a frame that looks like this. Now, I've done a lot of the prep work already offline, so I'm just going to share where I am in the process. First of all, what we have is the Supra 28.8 fax modem, although it's been gutted. The board inside looks something like this. There's a couple of Rockwell chips that are removed. I also desoldered the DB25 here, that's the serial connection, the two RJ11 jacks, and the power switch off the front. Unfortunately, due to the way that the modem was made, we have some circuit logic on the back of the board, so we cannot use this particular board. Instead, what I did was made my own. So ultimately what we're going to be building is a breadboard that has two 14-pin sockets. We'll have two sets of pin headers. Also that we can install our own 5x7 matrix displays. And now through the magic of editing, I have a completed part. On the back side, we have the pin headers. And if you look really close, you'll see little copper leads that connect the pin headers to the socket pins. It was tedious and time consuming, but I believe that will give us the most flexibility and the cleanest look. Speaking of electronics, there is quite a bit that needs to go into this device to make it work. We have power connector, power switch from the original modem, DB25 from the original modem, RJ11 from the original modem, a cooling fan, we'll talk more about that later. Here's the TTL board. This one looks a bit different from the one that I showed you before because this one is for wiring directly. We have some pin headers that I installed and a couple of leads because those will be the activity lights on the front display. Now to make the digital display work, I went off the shelf and picked up this LED matrix driver device. And what it has is our 5x7 matrices that is then connected to an I2C controller, allowing us to control the display using the Raspberry Pi and the I2C interface. Unfortunately, this particular device is too tall. It will not fit in the front of the modem, which is why I created this board with the extension. Now the question you might ask is, how do we connect the I2C controller to the digital display on the front? And that is where I did some work offline, and we ran extension cables from the I2C module to a set of DuPont pin headers that will now interface with the front board. Now the final device that we need to make this project work is a Raspberry Pi Zero. Unfortunately, you cannot buy Raspberry Pi Zeros unless you want to pay an absorbently high amount of money, but you can buy Banana Pis. This has the same form factor as a Raspberry Pi Zero, comes with a quad-core processor, and everything else is basically the same. Now to connect our GPIO pins to the rest of the device, we're going to be using a hat. For us to make this work, what we would like to do is not have the device so tall, but flatten it out. Now, the logical way would be just move it to the side. We have a ribbon that goes from here to here, and it will connect up the same way as if it was stacked on top. However, we want to leave the area in the middle open so that we can get our USB cable to connect here for power, and also use the center section for cable routing. So to make this work, what we need to do is flip the board over and rotate it. What that will do is align pin 1 with pin 1, allow us to separate it, have our cable chase in the middle, and still provide room underneath for our circuit building. And for our circuits, we'll need to hook up 5 items. The major one for this particular project is our TTL board. We talked about this before. The next item will be the I2C or I2C controller, and that will be for the digit display. The item after that will be 2 of the LEDs on the front panel. 2 of them come off of the TTL, and 2 of them will come off of the Raspberry Pi itself. The final item will be a standard cooling fan. For version 1, this will be hooked directly into the power rail. We'll be using 3.3 volts to keep the noise down, but in subsequent versions of this project, I would like to have it on the 5-volt rail and then allow the Banana Pi, Mango Pi, Raspberry Pi, whichever Pi we're using, to determine when that fan turns on based off of the internal temperature. Okay, it's final assembly time. I've done a little bit of prep work, mostly to put the front panel display on the plastic frame. Used a little bit 2-part epoxy. The gray stuff, I think you know what that is. So now we can get our sports installed. We have 2 that are specially designed for the Pi hat, and we have 2 that are designed to hold the Raspberry Pi, or in this case the Banana Pi. The next pieces we'll install will support the Raspberry Pi itself, and unlike the Pi hat where we have posts to raise the board up, these will be sunken in. When I designed this board, the intention was to give myself the most amount of flexibility when it came to changes to the design. And in doing so, I opted to use screws to hold most of the components together instead of glue. Unfortunately, the front piece needed to be glued just because of where it was and how it had to align to be properly installed inside the modem itself. But for these internal components, the idea is that we should be able to tear everything down, replace components as needed to fit new technology, new Pi hats, new whatever we wanted to do, and then replace components if needed. So for instance, a lot of the components that are in here do not have anything but pin headers. So we'll be using DuPont style wires to connect everything together. In the grand scheme of things, is that actually needed? Probably not, but that's how I design things. That's what I wanted to do for this particular project. And overall, I think it looks cool. Go ahead and get this placed down and lined up. With any luck, we'll get it the first try. Now with the internal supports installed, we have the Pi hat on the right, we have the Banana Pi on the left. Printed them in black just to kind of make it stand out a little bit better. Now the first item we're going to install is probably the item that we don't really need, but we have a 30mm fan. This is 30 by 7. 5-volt fan, so it'll work perfectly. Have power ports on the Pi hat for 3.3 and 5 volt, so we can dial in the noise and cooling level as needed. To install this fan, we're going to be using 2.5mm screws. Does this fan require 4 screws? No. There we go. Let's go ahead and install the Pi hat. This one is using 2.5mm screws as well. Put it in there loosely for right now because we will have some adjustments to make. Next part is a little tricky because we have the Banana Pi, but then we also need to install a heatsink. And the reason it will be a little difficult is because we have 2.5mm screws that need to pass through the heatsink, through a spacer, and then into the frame. Next thing we're going to install is the power plug and power switch. And the first part is to get the plug threaded in. Now once I got the power installed, I realized that I made a mistake. And if you guys can figure out what that is, please put a comment down below. Unfortunately, the Banana Pi does not have an internal antenna, so we're going to add one to the bottom of the frame. It does come with some stick-em on the back, and I got these off of Amazon, and I'll put a link down in the show notes below. I'm saving the most exciting piece for the very last, which is the digit display wiring harness, so to speak. Our first power on test is to light up the digital display, and as you can see, it's saying OK. The font is a little different from what was on the Supra modem to begin with, but we can work on that. The Banana Pi has a red status light indicating that it has power and is running. And the light on the back on the TTL board is lit up, indicating that the TTL board does have power. Now that we have the modem back together, let's go ahead and do a quick functional test. And to do that, I'll be using a vintage terminal program called QuickLink 2 Fax. This is one that I used quite often when I was surfing BBSs back in the day. Here's the startup screen. What we need to do here is make sure that the terminal is set to the way that we have the software configured. And for that, we need to change the modem speed to 9600 baud. Go into setup, Change the line settings to 9600. And what the software does is translates phone numbers into IP addresses. So for instance, we can go into our dialing directory. And we have Ninja Lane Labs, which is at 555-1000. And what that will do is translate the phone number into labs.ninjalane.com. Let's go ahead and dial. And here we have the Ninja Lane Labs Synchronet BBS. And go ahead and log in. Here's the Synchronet splash screen, the bulletins, and we're not going to look for messages. And here's the current main screen on the Ninja Lane Labs BBS. We can go and fire up a game, for instance. So we'll go into external programs, we'll pull up a DOS program, and say, hey, Trade Wars. Fire up Trade Wars. And as you can see, it is fully functional and working on the classic case build, which is a 386DX 40 megahertz. And there you have it. The Supra PiModem project is now complete. Unfortunately, what I determined is that even though I added an external antenna to our Banana Pi, it does not like being in this aluminum shell. The latency goes off the charts, so that will be something I'll have to address in the future. We still have a little bit of work to do in the software to enable the terminal ready and the off-hook lights, and also to hook the software into the double-digit display. As always, thanks for watching, thanks for subscribing. If you have any questions, leave them in the comments down below, and I'll see you in the next one.